So far we solved for total current. After we solve for total current, we can start solving for the individual voltage drops across each one of our resistors, the 75, the 150, and the 300. And it's just like Ohm's law, but in this case we're going to take the total current and multiply it by the individual value of the component, in this case the individual resistor. So in this case, the voltage drop at resistor number 1, if I take the total current and multiply it by resistor value number 1, I get 1.71 volts. I'll do the same thing for voltage drop at resistor number 2. Take the total current times resistor 2, and I'll get 3.42 volts. Resistor number 3, the voltage drop at resistor number 3, I'll take the total current times R3, and it gives me 6.84 volts. Now keep in mind, we did drop a lot of the decimal places here, so these values are going to be off just a little bit. So when we go to solve for total current, since we know that total voltage is equal to the total current times total resistance, we can backtrack ourselves and double check our work. In this case, if I take my total current and I multiply it by my total resistance, I get 11.97 volts. Okay, so and that's due to rounding. The other thing we can do as well, there's another formula for solving for total voltage, and in a series circuit, the rule for total voltage is the sum of the voltage drops have to equal the total voltage. So in this case, E1 plus E2 plus E3, take your individual voltage drops, should equal to your total voltage. In this case, we're close to it due to rounding or dropping the decimal places off, but 11.97 is still the same as far as mathematical purposes, 12 volts.